the advancement of the aviation industry, both in the military and civilian air transport sectors. Hello everyone, and welcome back to the Fluctus channel. The need for dependable, high-performance engine designs has become more and more necessary with the advancement of the aviation industry, both in the military and civilian air transport sectors. This need became very obvious as far back as the 1950s, when airplanes began switching from propeller-driven engines to jet engines. Aero engine manufacturers, too, have been in a neck-to-neck race to meet this pressing need, with Pratt & Whitney counting amongst the most successful of them. Headquartered in East Hartford, Connecticut, the company has been producing engines for both civil and military crafts since 1925. From reciprocating engines to turbojet and even rocket propulsion, the company has grown alongside the aerospace industry from the very start till this new age of propulsion systems.
What you're seeing with aircraft is they're becoming more integrated, and there's no better example of that than the propulsion system.
Pratt & Whitney's engines have been used on some of the United States Air Force's most popular and valuable aircraft. Among them is the F-35 Lightning, the newest generation of U.S. fighter aircraft that rely on specially designed Pratt & Whitney engine for propulsion. It uses a custom F-135 low-bypass augmented turbofan engine offering over 40,000 pounds of thrust.
The main thrust here is improving the emission-weighted fuel burn of this engine. We put in a package of advanced aerodynamics in both the compressor and turbine, shooting for a 5% reduction in fuel burn, and we pretty much achieved that goal.
The F-135 engine production line is one of the most mind-blowing marvels of modern engineering. It's a combination of automated work instructions, precise machining, laser ultrasonic inspection, automated drilling, and laser projection rolled together. Some parts of the engine are made in Lungale, Canada, and in Poland. The final assembly, however, takes place in Middletown, Connecticut, in the United States, where in 2014, Pratt & Whitney took engine technology a step further by switching from the vertical to the horizontal assembly system. This concept had been on trial in the company's branch in Canada, powering the CS series of aircraft. For more benchmarking, the team of engineers also traveled to Europe to study Audi Corporation's efficient R8 car's horizontal engine model. Horizontal aircraft engine assembly automatically eliminates all the tooling interfaces, leading to increased productivity. The reliability of this engine was also proven through the accelerated mission testing. This testing method is used to rapidly age an engine by causing it to accumulate several years of running time in a short amount of time, allowing for the identification and correction of issues before they could occur in normal use. Another aircraft that uses Pratt & Whitney's engine for propulsion is the C-17 Globemaster, a strategic airlift plane that has rendered heavy service since it first entered service in 1995.
They use it in a very challenging environment, and the engine delivers day in and day out. They take off from very short runways and unimproved runways, and having reliable thrust when you don't have much room is paramount to executing.
It boasts 4 Pratt & Whitney F117 PW100 turbofan engines, similar to those used on commercial airliners.
The F-117 engine is the revolutionary part of a C-17. It had the ability to go into desert locations. It had the opportunity to airdrop at very low altitudes in very austere locations with horrible weather conditions, because the performance of the engine allowed them to get into those places.
The B-52, another aircraft featuring the JT-3D and J-57 engines, was essentially built to carry nuclear weapons for Cold War-era deterrence missions. Therefore, the ability to save fuel while airborne was integral to its design. In fact, the B-52 continues to be the only aircraft in service with 8 engines. The interior of the B-52 is still very revolutionary for its age. The bomb bay doors open up to reveal a near-empty compartment, which can be stocked with any variety of bombs and other munitions. Along with engine redundancy, Boeing was careful to provide plenty of interior system redundancy to protect against potential failures. For instance, the B-52 features 6 engine-driven hydraulic pumps and 4 electric backup pumps, 4 generators, and 2 manual emergency landing gear extension and retraction systems. Below the cockpit is a tactical mission area where 2 operators work to keep the plane on track while controlling the aircraft's weapons. The plane was also equipped with the defensive aerial tail gun. Designed as a potential nuclear response craft, it was essential that the B-52 be able to get airborne very quickly. This led to what's known as the cart start. To execute this launch procedure, the flight crew, together with the crew chief, scrambles to the plane, where they remove pre-flight check flags and then enter the craft. Explosive charges are then used to fire up the engines, which would normally take up to 1 hour to warm up. In most cases, however, a cart start can have the B-52 going in 10 minutes. Besides the differences in the engine types and the unique starting methods of some aircraft, another distinct difference is the engine placement. Many planes manufactured by Learjet, for instance, feature rear-mounted engines, which are positioned near the tail on either side of the fuselage. The Boeing 727 is also known for this design, as is the Boeing 717, the CRJ-200-1000, and the McDonnell Douglas ND-8X series of jetliners. This is in stark contrast to the majority of large commercial and military craft, like the B-52 and Boeing 747, which feature underwing engines. Rear-mounted engines are ideal for protecting against issues related to engine failure. If one engine were to stall mid-flight, the pilot would have to deal with much less asymmetric thrust, as the engines are so close to the center line. When an underwing engine goes out, the resulting yaw can make it difficult for the pilot to maintain control. Unfortunately, rear-mounted engines are also extremely loud for passengers near the back of the plane. They also need a horizontal stabilizer to be placed above them, resulting in a T-tail design. By contrast, underwing engines are easier to service and do not result in the noise issues associated with their tail-mounted counterparts. This configuration also provides wing bending relief, which can reduce wing structure weight and allows for